So tell me a little bit about yourself and your background in IoT.
Sure. My name's Todd Greene. I'm the CEO of PubNub. My background has actually been as a software entrepreneur for the last 20 or so years. The vision of PubNub was, whether it's in IoT, whether it was in social gaming, whether it was in financial services, there were people rebuilding the same technology over and over again, which was real-time control of devices. Whether it was for doing chat applications or screen share or controlling devices in real time through firewalls, it turned out that there were basically replicas of technologies being built again and again and again for different industries. And companies were spending tens of millions of dollars to replicate what World of Warcraft did, and what Skype did and what Instant Messenger did and what Google Docs did. They were all similar.
Now, just to clarify, is this more on the infrastructure side you're saying the replication was happening?
That's right. So they were basically rebuilding the wheel or reinventing the wheel every time. So the idea of PubNub was, is there a single infrastructure which multiple industries could use to do basically data streams in real time and what later became lots of other services around those data streams? And basically leverage it in a way that cuts across as all these verticals. So we started PubNub on the side, and then we sold Oil Eyes to the owner of American Idol, which freed me up to raise a round of financing. At that time, PubNub was going about 150 transactions a second. And we already had about 25 or 30 customers. We knew we needed to raise venture capital to scale this network out. And the rest is history.
Okay. Now, so PubNub, tell me a little bit about the network or the data stream network, as you call it.
Yeah, absolutely. So as you fast forward till today, PubNub is this 15 data center global data stream network. And it's all replicated. So you can think of it as a layer on top of the internet. In the same way that someone like Akamai or other CDNs provided a caching layer for the internet, we provide a real-time data stream layer that has the context of a data stream. You don't have to worry about IP addresses or anything else. You simply publish data into our network, and any devices subscribing on a channel will receive that data in a quarter of a second or less. So we have a large set of customers now, about 1,000 actually, who use us across about 20 industries for real-time communication. Everything from simple chat applications to screen sharing applications to a very large increasing number of IoT, embedded device applications. Sometimes it's a very blurry line. Sometimes you go from embedded device to mobile to server to browser. But basically you're getting a real-time data stream synchronization, and you're getting it across any kind of device anywhere in the world.
So now, is this a messaging-based system? Is it a message-based system? And how are you ensuring the real-time air quote kind of component?
Great question. Well, we use a lot of concepts from the messaging world. So we use the concepts of publish and subscribe, and that's where it started. But we don't really compete with, say, behind the firewall messaging devices. We really start by opening up an always-on socket connection to every single device. Now, that's hard to do through firewalls, through spotty cell towers, keeping them alive. It turns out the way you do that is different on just about every kind of device, embedded systems, mobile devices, and everything else. So we kind of call this the land of 1,000 paper cuts. We don't solve one particular problem. We just ensure that when you publish a piece of data, that it's going to get to the other side as fast as possible. Now, if you have a decently fast internet connection, you are going to basically get a quarter second or less. In fact, the reality is, if you're in the U.S. or actually within about 1,000 miles of one of our data centers, your round-trip latencies are about 30 milliseconds. So about 10 times faster than our quarter second.
Like for a ping, or what do you mean?
You publish a message, the other device next to you will receive it in about 30 to 40 milliseconds. Obviously, if you're on a slow edge network with spotty connectivity, it may be longer than a quarter of a second. But we have people doing synchronous games with it. We have people doing screen sharing applications with it. And what we've learned is that by having a socket connection open to all these devices, we can offer really a whole set of services related to being directly connected to those devices.
And what type of services?
So if you look at our footprint now, we started as this high-speed, high-scale, low-latency messaging service. But one of the very first questions customers ask is, well, that's great. And I'm publishing data, sometimes up to even over 1 million devices at the same time. So one publisher and 1 million people listening.
Wow.
But I want to know when people are listening, when they're subscribing, when they're gone. So the non-technical way to think about that is like if you use Skype, there's a green dot if someone's there, and a gray dot if they go away. For PubNub, we abstracted that to something we call presence. Now, presence is obvious in a social application. If someone's logged in, you want to see that they're there. But we also do that across any kind of device. It turns out this is really big in IoT. Because in IoT, a lot of times you'll deploy many devices out in the field. And if some number of devices disappear, the IoT vendor often gets blamed. But if they're using PubNub, they can show exactly when the connectivity fell apart, and they can show when it reestablished.
Okay.
So you can show things like cell towers going down, network components going down, because we're giving you real-time capabilities to see when those devices were there. And that's not just for your servers, but that's also for any other devices that want to see if, say, a peer device is connected.
Right.
So they can publish between devices.
Okay.
So presence is one.
That's important.
The other kind of obvious next step was storing and playing back those streams. A lot of the data sent through PubNub is what we call data that may have a half-life of a quarter second.
Okay.
Temperature reading, a movement of a car, something like that, a lap long, things like that. However, what we found is a lot of times you want to also retrieve that data very quickly. I'll give you a great example. One of the more common uses of real-time connectivity is to do things like device provisioning and firmware updates and things like that. You want to publish out a firmware update message. Imagine if a device is offline. You blast out a firmware update message. Now, the devices that are turned on get it immediately. The ones that are offline, as soon as they boot up, the first thing they do is go to our storage system, retrieve the last known message on that channel, right? Basically do the firmware update, register, so they trigger presence. We know the device is now online, and they start listening for the messages. So those three services, presence, storage and playback, and just the core PubSub service, provide the backbone for lots of home automation solutions like Logitech, Insteon, Vivint, Revolve, Quirky, a whole bunch. As well as connected car solutions. For example, Lyft, Sidecar, Get Taxi, and many other car telematics type of solutions. Turns out across the board, there's use cases for all of those.
So home automation, telematics, is that what you're seeing as a sweet spot in the IoT part of your business?
Well, there's other categories as well, but what's interesting there is there's actually many categories of IoT. One way to look at IoT categorization is sort of what people are doing with the data. A lot of IoT today is about collecting, data collection. And there's a lot of ways to skin that cat. We actually help there as well. But one of the things you'll typically see is that while maybe 95% of the data is being collected today, there's always these use cases where you also need to turn around and control that device.
Right.
Now, and also in many cases, that's real-time control. And that's the place where we completely excel. That's the place where we have no equal. You can publish a message, we replicate it across 15 data centers globally and out to any devices near there. So if you think about that for, say, a dispatch for transportation, whether it's a taxi dispatch, delivery dispatch, things like that, you've got real-time signaling to these cars and real-time signaling back the other way. If you think about it in smart home, well, it used to be that in home automation and smart home or industrial automation, you had to be on the same network, same local network to control your lights or your garage door. But nowadays, you're at a restaurant, you want to see what your kids are watching on TV, your security system triggers, you want to know that somewhere else, or you're driving home, you want to open the garage door. You don't want to have to think about, am I connected to my home Wi-Fi? Am I on 3G? Am I on some other network? PubNub makes all that invisible. So one of the reasons we really resonate in the smart home space is that it's simply plug and go.
Right.
You hook your home hub to your wireless network. It registers through PubNub, and then in a completely secure way, we provide a real-time, kind of like almost like a VPN, a real-time encrypted tunnel to that hub that works through your home firewall. So now, if a hacker port scans your home, it doesn't even look like there's a computer there, and yet in a quarter of a second, you can be driving home, open the garage door, turn on lights. And it's completely irrelevant on what network you're registered. So you could be on your cellular network, your connected network. So there are definitely industries where PubNub becomes, in the IoT sector, where PubNub becomes really invaluable for making products friendly from a deployment and usage perspective.
So the usability behind the home network, is that the 1,000 cuts you were talking about? So you have different use cases that you just make it work, or
there's if you look at these different industries, there are problems that we solve in each industry. For example, let's move on to transportation. I'll go back to smart home. In transportation, many times when you're signaling a vehicle, you want to know that vehicle got that information quickly. But in the case of transportation, you're constantly losing your cellular connection, right? You're going through tunnels, switching cell towers, switching from 3G to 2G to 4G, and so on. If you're if you're looking for a real-time signaling solution, then you're keeping a socket open. Every time that switch happens, you go into a tunnel and you drop that socket.
Right.
So PubNub, one of the many, back to those 1,000 paper cuts, one of the many things we do is you're publishing data to one or more devices or vehicles in that case. We're timestamping every message to the nearest 10 nanoseconds.
Okay.
We track every device and which messages they've received. So now, when a device comes back out of a tunnel, we can catch them up very quickly, very sort of silently to the data that they've missed.
Okay.
And now you know that in a very highly reliable way that they've got the data.
Okay.
In the case of smart home, we do all of that. Now you have less of an issue of connectivity at home. Generally, your internet connection works. But the problem is you have firewall issues. We get through corporate firewalls, home firewalls. One of our home automation customers used to spend between 7 and 20 minutes per retail customer to explain to them how to reroute ports on their firewall.
Not easy.
Right? Today with PubNub, they simply plug it in and it works. None of that goes on anymore. So it provides a much, much better consumer experience.
Okay. Now, PubNub is a public, worldwide network. Now, why would someone use the PubNub platform versus purchasing their own platform or renting one of the platforms that are perhaps, maybe that's the answer. Is it because they're industry specific, or why go with the PubNub versus, say, one of I guess 200 or 300 other platforms, IoT platforms that are out there?
That's a good question. So I think it's important to point out we're not an IoT platform.
Okay.
And
so where do you draw the line? What is it that you do within an IoT platform? What don't you do there?
Yeah, great question. So whenever there's a new emerging technology, in this case IoT, the initial wave of vendors typically are platform vendors,
Right.
one-stop shops,
Okay.
combination of products and professional services. Today's IoT platform vendors are 70 to 80% professional services, 20 to 30% product. And that's actually great because people who want to get into IoT,
they need the help.
They need the help. They don't know what's going on. They're looking for someone to provide them a solution top to bottom. And then as industries start to mature, we start to see an understanding and evolution of the technology stack. And you have best of breed players for every layer of that stack, right? And they're interoperable. Today, when you build a banking website, you don't reinvent security. You don't reinvent analytics. You don't reinvent the database. You don't reinvent the platform on which you're going to have user interface.
Right.
We all know how to do that. In fact, you can get people right out of college who can build you a pretty good, secure website today. That's not the case in IoT. And I think that in this early stage that we're in, there is an opportunity for platform vendors. But we see ourselves as the data stream layer of that communication stack. Okay. So there are IoT platforms who use PubNub today for communication. We are narrowly focused on being the best global network for any kind of device-to-device communication.
So device-to-device communication.
That's right. And in the same way that you may ask a question of, let's say, are you familiar with Akamai or CDNs, how they work?
Yes.
So you may say to an Akamai, well, why does someone use you versus buy a web server? Well, that's a great question. They're saying, look, there's a lot of ways to serve web content. What we give you is infinite number of places where that data is cached, so you're one hop away from 80% of the world's population, and a lot of other benefits around performance, reliability, scale, and so today I think they serve 20 some odd percent of the entire internet's traffic, and the rest of the CDNs together, are a large part of it as well. So in that same way, we are the definitive way to do reliable global signaling. And if you think about the world, technology evolution in the world today, almost everything on the web has been built off a request-response model. I request data from a server, it pushes it back, sends it back out to me. That works in IoT, but it works in banking applications and lots of other places, even just surfing the web. But that's changing. We're now moving into a world where there's a constant emitting set of streams of data. We started to talk about data streams back with social web. We had Twitter streams and Facebook streams and social streams. But we also know we have temperature streams. We've got tide and traffic streams, and we've got air travel streams. We have location of vehicle streams, financial streams. And these are just streams that are constantly emitting data. And this idea that they're all going to be funneled into this old, in a traditional sense, database that will later go to request information out of, that still will happen in some cases. But the amount of streams are getting larger and larger. And the desire for us to have real-time information and real-time access and visibility and processing and filtering of these streams is getting higher and higher. And so PubNub provides that global data stream network, hence the term data stream network, that allows you to submit any number of streams on that network. It allows you to subscribe from any number of devices to a subset or all of those streams, and allows people putting the data on the network to now syndicate that data, not just to their end users, but to business partners.
Okay.
So we also become now a global syndication layer for data streams.
So then I'm still trying to discern the difference then, other than the analytics and the model. Is there any other difference then between a PubNub and a traditional IoT platform?
Sure. So I'll finish this. A good question. So companies that provide IoT platforms, like I said before, will come on board and provide some product and a lot of professional services. We are very focused on just being a data stream network. We don't have professional services.
Okay, so that's one big difference.
Exactly, very big difference.
And technically, though, what are the differences on the technical side?
Absolutely. So we're just focused on data streams. If you think about the many layers that a platform provider will try to provide a solution, they'll do databases, they'll look at analytics, they'll do embedded device design, even for some people, some firmware connectivity, perhaps local area connectivity, Bluetooth, mesh network, things like that. And then they'll connect it together in some way that may or may not be scalable between the devices and the servers. So we have IoT platforms that develop with PubNub. We have people that have done it before that use PubNub, and we did it across 20 industries. So in the same way that we there's a lot of analogies out there, but we focus on just the transport layer of data over the internet.
Okay, over the internet.
Over the internet, exactly.
So if I'm to draw this out, then the ragged edge, nope. But maybe from the gateway to the internet,
exactly,
and then from the internet to your local system, which is going to have your analytics, your model, or your database, and the rest.
And then we provide a lot of hooks so that raw data coming out of PubNub can be plugged into any analytics system. So we provide some analytics out of the box. We've got real-time dashboards and graphs. We've got the ability to see the amount of data flowing through our network. But we also give you this way to fire hose your data into both visual analytics platforms that exist. We have a lot of hooks into things like D3JS, which is a nice open source set of libraries for visualization. And basically, today we support over 70 SDKs. So if you are basically developing in Java, .NET, and PHP, and Python, embedded systems, we have over, I think, 12 embedded systems libraries. Our SDK, our APIs work exactly the same. And we basically will hook into just about any backend system for analytics, for processing, for reporting, for triggering. And so it's very easy to plug your devices into our network, have them talk to each other, and finally have them talk to the backend systems.
All right. Well, makes sense. Thank you very much.
Really appreciate the time. Thank you very much.